Okay, so we're going to call this 4.1. 4.1. This is the first lesson in Unit 4. This will not be on your test Monday. Your test Monday is on Unit 3. Okay, so we are going to be solving radical equations. So if you want to put a title at the top, you can put Solving Radical Equations. So to do that, our basic steps are that we need to isolate the radical. So we need to get the radical by itself first. Then we square both sides so that we get rid of the radical. Then we solve the equation that's left, which sometimes will involve factoring. And then we check to make sure that we don't have any extraneous solutions. Extraneous are solutions that we come up with algebraically that aren't actually a solution. Okay, so sometimes we're going to get two answers, and one of them may not really be an answer. So as we do that, I will model that so you will know what's going on. Okay, so example 1. Is everything under a radical sign? Yes. So we don't have to do step 1 of isolate the radical. Everything's already under a radical. So we are squaring both sides. And you know that squaring gets rid of a radical sign. So it basically just gets rid of that. So now what we have left is negative 12, minus 2x equals 2x plus 20.
Well, that looks familiar.
It does, kind of. Except that negative 12 doesn't look quite like negative 12 should right there.
It's like a negative, like the 1 and the 2.
All right, so then how do we solve that? We've got to get our x's on the same side, right? So this is just back to an Algebra 1 kind of question. So like I may subtract 2x. I like my x's on the left. It's just kind of how I roll, but nothing magical about that. We're going to get the same answer no matter which side we brought them to as long as we finish it out. And then we would add 12 to both sides. So that would leave me with negative 4x is equal to 32. And then when we divide, we get x is negative 8. Okay, now we need to check this. So if we put negative 8 in for both equations, so I'm going to try to do this out to the side because I, of course, left absolutely no room. So negative 12, what is negative 8 times negative 2? Positive 16, right? That's under a radical. So this, because it was to start with, because I'm going back to the original problem, negative 12 plus 16, that's 4. So that says square root of 4, right? Square root of 4 is 2. On the other side, negative 8 times 2 would be negative 16 plus 20. This is, I'm working on the check. That makes the square root of 4. That's also 2. Is 2 equal to 2? Yes.
But now the negative 8 is...
Negative 8 is the solution. Okay? Negative 8 is our solution. The reason we're doing the check is because sometimes we're going to have extraneous solutions that are not actually the answer. But in this case, negative 8 checks out. It works. So we're going to go over to number 2. So on number 2, everything's not under a radical, but is everything on the side where there is a radical, is the radical the only thing under there? Like there's nothing outside the radical on the left. So again, we don't have to do step 1. We're ready to square both sides. So when we square this, on the left side, squaring is going to get rid of the radical sign. But on the right side, there was no radical, so it's going to get us squared. Yep. So now we've got 2 minus x equals x squared. And if I want to solve and I have a quadratic, I have a squared term, I need to get everything on the same side set equal to 0. Now, we want to put it over there with the x squared. We don't want an x squared to be negative. So we're going to add the x and subtract the 2 so that I have 0 equals x squared plus x minus 2. Are you guys with me on how I got that? So I just pulled everything to one side so that it's set equal to 0. What do you think I should do next to solve this? Factor, yeah. And is there a GCF? No. So then our next thing we would do, x factor. So what goes in the top of my x, Dalton? -2. And in the bottom, just a 1. So what two numbers would multiply to be -2 and add up to +1? -1 and +2. We can use the shortcut. We do not have to split the middle because x squared was just x squared. It's not a number. There's not an a value. It's just a 1. So x and x minus 1 plus 2. That's equal to 0. So then when we set both of those equal to 0, then x is equal to 1 and x is equal to -2. And then we need to check these to see if they work or if one of them might be an extraneous solution. So if I plug 1 in, what is 2 minus 1? 1. What is the square root of 1? 1. So he passes. He's good. If I plug -2 in, 2 minus -2 is 4. And the square root of 4 is 2. We do not want to use the negative square root. This guy is what's known as an extraneous solution. It is not, yes, algebraically you get that, but your final answer is only the x equals 1. So now we're going to look at number 3. And on number 3, we will need to do step 1.
I'm kind of a little lost.
Okay. Okay, so now before we can square both sides, on the side with the radical, everything would have to be underneath. No, you can't just shove the 4 underneath there. That doesn't work that way. We got to move the 4 to the other side. It's currently a -4, so how would we move it to the other side? We would add 4. So we're going to add 4. Whatever I do to one side, I still do to the other. Some things never change. And then this becomes n plus 4. And then now we need to square both sides to get rid of the radical, because that's step 2. So I square this side. That just gets rid of the radical sign. That side's nice and easy. What about over here? When I square this, John?
It becomes n squared plus 16.
No, not quite. It becomes n plus 4 times n plus 4. So I will end up with an n squared, but I will also have, I'm going to write it kind of down here. I'm doing this, right? And I got to distribute that, so there's my n squared. I also have 4n and another 4n. So in the middle, after I combine like terms, I've got 8n. Does everybody see where the 8 comes from? Because 4n and 4n. And then that 16 that John's already mentioned. N times n. These two. So I have to, it's that whole thing in parentheses squared. So, good. Because we had to square both sides, and that was not under a radical. Now we have an n squared, so everything needs to be set equal to 0. So I'm going to let this be 0 over here. I'm going to subtract the 6n from the 8n, because the 6n needs to move to the right. So plus 2n. And then 16 subtract 15 plus 1. Yeah, Mitchell.
Does it matter if you subtract the 8 from the 6?
You want your n squared term to be positive. Okay, so you don't want your quadratic term, your squared term, to be negative. So that's why I subtracted the 6n. And then we're going to x factor. So 1 is on top, 2 is on the bottom. 1 times 1. We only have so many choices available there, right?
Yeah.
So this guy's going to look like n plus 1 and n plus 1. So now when I solve that and set it equal to 0, then n is equal to -1. And I get the same answer from both of those, right? Okay? Now, when you plug that in, at first you might think, but isn't that going to be one of those extraneous solutions? How did I go up?
How'd you do that negative?
Because n plus 1 equals 0, and I have to solve for n. So I subtract 1 from both sides to get n by itself.
Oh, okay.
Yep, got to do that little solve step. So if n is -1, then in my radical, see if I can find a spot to write that. Ooh. So that's -6. -6 plus 15 is 9, right? So the square root of 9 minus 4, we want to see, does that equal -1? What's the square root of 9? 3. And 3 minus 4 is -1. So I'm not saying that the square root is a negative. I'm saying 3 minus 4 is -1.
I do have one question. How did you get the 9?
6 times -1 is -6 plus 15. So that's just when I'm plugging in the -1 back to the original equation to see if it works.
Okay.
All right. That was sarcasm. On number 4, do we need to do anything before we square both sides? Nope. So we're ready to square both sides right from the get-go? That's pretty good. Okay. So what do I get when I square both sides then? Taylor, what do you think?
You get a -63 plus 16n.
And then what do I get on the other side when I square it?
N squared.
Good. So when we square both sides, the side with the radical, that just makes that radical go away. And this guy gets a squared. And now n squared, we want that to stay positive. So we're going to keep n squared, subtract 16n plus 63 equals 0.
Why is it plus 63? This is negative.
How? Because we got to take it over. We want the 63 over there with the n squared. So how would I move it off the right side?
Oh, you got it. Never
I'd have to
mind.
do the opposite. No, that's good. Good question. It's not magic. I'm going to make sure I'm not doing witchcraft or anything. And now, x factor. So now when we x factor 63 and -16. So what numbers did you come up with? Mitchell? Negative 9, negative 7. So in my factors, I have n minus 9, n minus 7. So now when I solve and set those equal to 0, n is equal to 9, n is equal to 7. So we need to see if one or both of those work as our answers. Because remember, we could get an extraneous answer and have to X one of them out. So what is 16 times 9? You may want a calculator. 144. Why am I even asking you what 16 times 9 is? Because I plugged it in. You got it. So I want to see if 9 is equal to negative 63 plus 1. Okay, so then what is negative 63 plus 144? 81. Is 9 the square root of 81?
Yes.
Yes, so this guy looks good. Now let's go check out the other one. So I'm going to erase my work down here to give us a little bit of space. And then 7. What is 7 times 16? 112. So negative 63 plus 112. That's 49. Is 7 the square root of 49? Yes. So this time we actually do have two solutions. Wow, what a messy paper I have. Okay, so the next page is the homework over radical equations. Homework 22.